Hello, everyone. Welcome to our webinar on making sense of quantum computing for business. My name is Andrew Shipilov, and I'm a professor of strategy at INSEAD. And today it's my privilege to welcome two experts with whom we're going to discuss everything related to quantum. The first speaker is Denise Ruffner. So she is Vice President for Business Development at IonQ Inc. Then we'll also have the pleasure of welcoming Kevin Eversmann, who is the Managing Director of Accenture. So before we go further and before we dive into this question of quantum, it would be interesting to share some thoughts about the profile of people who are joining us. So the majority of folks here on this call are from the US and from the EU. And this is great because we also have about half of the participants who are mostly, half of our participants are alumni of INSEAD. About 13% are MBA students, and then there's also some participants from executive education program. So this is a very diverse gang, and I'm sure we will have a very interesting discussion. Let me ask you first, before you go, a set of poll questions. So my dear colleagues, Pascal, could you put out the poll? And this is the poll, there's only going to be one question. We would like to know, what is your experience with quantum? Meaning that, are you working with quantum? Are you the quantum entrepreneur? Do you want to work for a quantum company? Do you work for a company that would like to leverage quantum? Maybe you're just curious, or maybe you are in the wrong webinar. So let's see, we'd like to get your answers to these questions. And when we have received maybe 150, 200 responses, it would be time to hear and see for us what the folks have been saying. All right, so the majority are curious. Well, that's not surprising. INSEAD community is composed of intellectually curious people. But we do have people who are working for quantum. This is good with quantum. We've got people who work for the company that like to leverage quantum. And there's also some people who are the quantum entrepreneurs. So I think this is the time for us to educate the audience about all the exciting opportunities that quantum has to offer. So let me briefly introduce the speakers. So Denise, she's a leader in helping quantum companies scale. She is an early employee of IBM Quantum. She brings a lot of experience, not just from the startup world, but also from the corporate world. She has contributed significantly to overall quantum ecosystem. She has started the One Quantum Worldwide organization, Lead Women in Quantum. She is a quantum networker. She says that she networks unlike anybody else. So we'll really be interested to hear her secret sauce about networking and quantum. Lives in California and likes to travel and swim. Kevin, he is with Accenture, and he has done quite a few consulting and research projects, both related to quantum and also related to IoT and the industry. He has been working with BMW as a part of the Accenture relationship. He has been an applied intelligence lead in the technology strategy, has been an advisory automotive lead, and he has a lot of expertise in the manufacturing and the automotive segment. So when people ask Kevin about his goals and ambitions, that is to help clients to transform on their journey from technology and data to value and delight. And he is a keen ecosystem builder. So again, we would like to hear from Kevin about how Accenture builds the ecosystem of quantum and what is his secret sauce of ecosystem and networking. So, but now let's go to Denise, and let me ask Denise to come online, please. Would like if you could turn on your microphone and your camera. Hello, Denise. Thank you for getting up so early for us, and we would like to hear your story. So you sent us a few slides about your journey and about quantum in general. So the floor is all yours. Please let us know about quantum, your journey, your experience, and what your company has to offer.
Great. Thank you, Andrew, and welcome to the audience. Thank you, everyone, for joining us. It's a pleasure to talk to you. What I want to talk to you and start off today is talk to you about the company I work for, which is called, excuse me, IonQ. And basically, quantum computing in the past has been dominated by the big companies, the IBMs, the Googles, the Microsofts. And what's different is I joined a startup that makes quantum computing hardware, and I'm going to talk a little bit about it, but I'm going to get to the point now. We're going public actually a week from Friday. So it's exciting, and I'll talk about that a little bit more. Our company has a lot of history in terms of our scientific our chief scientists. So they are two people named Chris Monroe and Jungsing Kim. And what's interesting about Chris and Jungsing, and in particular, I'm going to focus a little bit on Chris on this talk, is Chris was actually the first person ever in the world to demonstrate the idea of a working quantum computer. So he showed the first quantum gate. So the first time kind of a quantum gate worked. And he did that in actually 1994. It was published in 95. And he did this in a lab of David Wineland, who ultimately got this the Nobel Prize for this work. Chris and paired up with Jungsing, and they both have made significant contributions in the field of quantum computing. And this ended up in 2015, where they published a paper. And a venture capitalist called them up and said, wow, I really like this paper. It's a business plan for a company. And that is the start of our company. So if we go to the next slide. All right. So today, and this is prior to the IPO, we have had 6 generations of hardware. We've spent about $50 million to date. Have a large war chest from our VC money, and we continue to progress with our systems. So our quantum computer is now on the Microsoft and Amazon cloud, and we recently put it on the Google cloud as well. So people can access it via the cloud just whenever they want, which is a really nice feature. It makes it very accessible for you to try it out and see if you like it and play with it a little bit. So if we go to the next slide, we are going public. It is through a SPAC, a special purpose acquisition. We're really excited about this. So literally we're going to New York a week from Friday on October 1st to ring the bell. And this is significant, really, and the reason why I'm making such a big deal out of it is because it shows that the financial markets are now supporting this technology. And so this technology that those of us in the industry have been here for a while have always heard, oh, it's far away, oh, it's experimental, oh, it's this. This technology is here, it's real, the financial markets support it, and I think it's a very exciting, I'm going to have a very exciting impact on the world as we move forward. All right, next slide. So how powerful are quantum computers? So when we talk about quantum computers, and you probably read in the newspaper occasionally about quantum computers, right now a quantum computer, depending on the computer, has these units called qubits, which is similar to a bit in a classical computer or a regular computer. And if we have a computer with 20 qubits, we need the memory size of 8 megabytes, and that's available in a cell phone. So computers are a little bit small right now. Now, if we go to the next slide, and you see if we go up to 50 qubits, then the computer starts having power, and you need a memory the size of 9 petabytes, and that would be available in a supercomputer, just as you see in the picture today. Now, our goal with quantum computers is to go to a lot of qubits. Here, if we say there's a computer with, if there is a computer with 160 qubits, we would need 10 to the 50th, we would need a ton of memory. And that memory is equal or bigger than the number of atoms on Earth. So these computers are going to get very powerful very quickly. Right now, we're still really on the first slide. So in the 20 qubit range, just simply because of error and error correction. But if we go to the next slide, what I want to show you is that there are literally hundreds of use cases for these computers. And it's really only as limiting as our imagination. Now, quantum computers are good at certain types of problems. I think when I first started quantum computing, I had a background in high performance computing. And we all look at those pictures where those computers are so big and you think, wow, a computer this big should be able to solve just about anything. And it turns out that there are certain classes of problems that no matter how big the computer is, they're very hard to solve. And quantum computer will be able to address many of those problems. And we're very excited about this potential. And if you want, during the discussion, we can talk about potential applications. But literally, the world is at our feet. People talk about batteries. People talk about a supply chain. I'm sorry, it's like 7:15 in the morning. Supply chain, all sorts of areas where these computers can make an impact. So I want to switch up and talk a little bit about the ecosystem. So I started the startup program at IBM, and I've always been very involved in the ecosystem. And what's interesting is there are countries all over the world that are very interested in quantum computing. And I've just summarized it in this slide to show you the investments being made. Right now, the top investment is from China. And interesting, number 2 is from Germany. Germany is doing a lot in quantum computing. And I'm glad Kevin is here to talk about that. But you can see that governments around the world are investing in this technology because they realize how much innovation it will bring the companies in their country, and they want to encourage this growth. Next slide. The hardware startups like my company, IonQ, are proliferating. You can see there's literally 60 to 70 companies now in the world, and you can see the different levels of funding. Our funding level that we show here is post-IPO. And what that means is we're going to have a nice size bank account for which to fund a lot of very aggressive development on our systems. All right, next. There are also many customers that are dedicated to writing software for quantum computers. It's a huge market. Think about the uniqueness of software. The same software that you use on a classical computer does not work on a quantum computer, so it needs to be completely rewritten. And so there are a lot of quantum software companies out there that are very exciting. I noticed a participant from Entropica in Singapore, great company. There's a lot of really good software companies. Next slide. I'm getting time messages, so I'm going to move. Overall, the market is small. The overall market size, and that's because right now the computers are very small. As the computers get bigger, I think we're going to see a complete explosion of opportunity that this technology will unlock. Next. Now, this is an area that's really interesting. The workforce in quantum computing is still very technical and scientific, and there are huge opportunities for people that want to join, I'm going to say, the quantum revolution. I think there's roughly 1,500 jobs open right now in quantum computing. And you don't have to be a quantum physicist to get a job. And so what I would encourage all of you, if you're looking at your career, you may want to take a look at quantum computing. and think about joining this really great emerging segment. Next slide. Andrew, next. Oh, I see your lips moving.
I changed. Did you say career opportunities for all are emerging?
Okay, thank you. So what I just said is that there are roles for people, whether you're a physicist or not. And so I want to encourage you, we need marketing people, we need salespeople, we need strategy people, we need accounting. So there's a lot of opportunity for everyone in this field. All right, next. All right, big challenge in diversity. And one of the things that we see is that when you look at people in this community, right now, it is not a very diverse group of people. So when we analyzed about 650 startups, we saw that the majority of executives are white males. And we feel that there is room for diversity. And this is part of the reason why I've started a group around diversity in quantum computing, because I feel that it's so important to have different points of view in a company. And I think that might be my last slide. Yes.
Yes,
So,
this is your last slide. Thank you, Denise, for this very concise introduction to the history and what for the quantum computing and what's in store in the future for your company. Kevin, so you represent a slightly different organization. You are not a startup. You are a consulting company, Accenture, which has done a lot of work in the technology space in automation and computation, helping clients understand this complex world of technology. So when from your vantage point, so what do you see in quantum? What opportunities do you see in that industry? What are your clients asking about quantum? And if I were the client that came to Accenture and say, can you tell me where quantum could create value for me? What would your answer be?
Yeah, thanks, Andrew. Thanks for this great question. So, as you said, we are a consulting company in the meanwhile with more than 600,000 people worldwide, and we are focused on technology and also how we call that emerging technology, and quantum is definitely one of them. And I think, Denise, what you already said, I just can echo, right? The clients are investing heavily into quantum because they don't want to lose the bus they already lost when it came to AI. So we are also doing a lot of stuff in the area of data, big data, and AI and analytics with our clients. And what we clearly can see is that they are investing right now into quantum. So when we look into some statistics, for example, more than 56% of the Fortune 500 are already investing now into quantum. So that's massive. That's massive. I think also, Denise, just to echo what you said in terms of investment, especially because you already said it in introduction. I'm from Germany, so Germany invested overall into AI 2 billion, and they are investing the equal amount of money into quantum now, which is, I think, a big message. So this is also in line with what our clients are saying and doing. So they're really investing into this technology. I think what you also can see is that, and we recently launched a study and also worked with this organization, which is called CureTech. So 13 companies are really committed to drive quantum computing forward in Germany and also in Europe. And the involvement of C-level is amazing. So you mentioned that, for example, the BMW organization CEO Oliver Zipse is personally involved there and fully committed. We have seen also Reinhard Ploss, who is from Infineon, as well as also when we launched that consortium jointly with our clients, that Peter Altmaier, as the German Minister of Economy, was personally there and is also committed in that space. So that's one angle of how we can see what our clients are doing and what we are doing for our clients. What are the requests we are getting? One for sure is that we jointly with our clients access their kind of setup for quantum. And this can have different angles, right? One, for example, is the technology itself, right? That they want to learn more about it. And as said, we also have this emerging technology organization within Accenture. We also have great partners we are working with on one side, for sure, the hardware players and technology. Denise was just listening, and also Denise is one of them, right? We are also working with research institutes. So that's a really, really big and broad partner ecosystem. On the other side, we are also helping them to set up their organization and also to help them to get the right skills in the market, because we all know, right, this is a war of talents. That's something where we can also help our clients to get the right people, the right talents ahead. And then what we, and this is now a little bit kind of advice we are giving our clients and how this should be implemented into their journey. All these companies are already or have started to invest into data, into AI business. And what we do and what we do jointly with them is that we already prepare right now their kind of machine learning models, so that whenever quantum is really ready to use in the industry, right, that we can do then the shift and say we don't have to start then to create the new models and things like that, and software also Denise was talking of, right? So this is something which typically we as Accenture do. As we all can see, this is just the beginning of a journey. All the predictions we are seeing is that by 2025, right, which is not too far away, only 3 to 4 years, we all believe that quantum gets really into industrial setup, so that companies all over the world will really use it and can use it.
Thank you, Kevin. This is very interesting. And Denise, so I'm, ever since I had this opportunity to speak with you, I wanted to ask this question. So tell us about the use cases. So the technology is amazing, the academic background of people who put together, both your startup and sort of built the foundation, pretty impressive. How can people make money with quantum?
So use cases, people can make money as the quantum computers evolve. Right now, as Kevin said, there's a lot of investment. Where we're seeing a lot of people starting quantum computing research is in banking. Most of the major banks have huge quantum groups, probably the largest being JPMC. Automotive, which Kevin is working in, is another big area for quantum computing, whether it's supply chain optimization or traffic optimization or even paint shop, or there's all sorts of different applications there. And then the other area that I really like is chemistry. A lot of the pharmaceutical companies and materials companies are using quantum computing to speed up drug screening or drug design, as well as looking at developing new materials that can improve, maybe have less environmental impact. So there's a lot of areas. I feel like it's bounded by your imagination, and there are a lot of areas where quantum computing can help. And I think what's most fun probably for all of us is to get in a room and talk to someone who's really creative and just come up with some new ideas on how to apply this technology.
Would you agree to the statement that quantum is a way to compute faster, more efficiently, requiring less of a physical memory on the hardware? So would that be right?
So quantum computing ultimately will be faster, absolutely. And so there are problems that take years to compute. And with quantum computing, they'll be able to be computed in a very short term. So the part of the promise of this is that you not only have this really powerful computer, but you're able to use it very quickly. So in the finance markets, it can, where a second makes a difference, I think quantum computing will have a huge impact.
Brilliant. Okay, and Kevin, so you mentioned that Europe already, or Europe and the US have lost the race in AI. So can you elaborate on sort of why do you say that, and how do you think European companies can catch up with other parts of the world, especially if you look at China, for example, they're making massive investments in quantum as well. So what is your sense about this?
Yeah, so when I said that they lost a little bit the bus, right, or were late in the game when it came to AI, is we have seen that really these tech companies in the world, right, that they were really early movers and have invested heavily into these kind of technologies, right, and also into skills and talents. Whereas, let's say, at least the typical DAX companies in Germany are a little bit more conservative, right, were investing slowly. Even the whole country has invested slowly into AI. And this is something which they have and can catch up now, and they are catching up, right? That's not a question. But I mean, time is an important factor, right? And what Denise was just mentioning, right? Imagine if you can, with a quantum computer, predict traffic, right? Much better than you can do it today with all these electric vehicles, with all this mobility vision these companies have. This is a big business benefit, as well as competitor benefit. So that's something the companies clearly see also when it comes to material, right? I mean, sustainability is on top of all our minds, right? We have to make sure that we get this 1.5 degree under control and don't exceed it, right? They all believe that also quantum can have a big impact on that by, for example, finding the right material when it comes to, in the automotive space, for example, the batteries they are producing and doing researching on that. When it comes to the material you build the car of. When it comes to, and we all see this semiconductor shortage in the world, right? It's a supply chain thing overall. If you can solve this problem much faster and better, this is a clear benefit. You don't have to stop the production maybe. So that's something I meant when I said, okay, they see this real benefit in quantum. That's why they are investing, and that's why it's a clear priority for some countries as well as for companies.
So Denise, you clearly have an amazing startup with an amazing track record. And when startups become publicly traded companies, the question that people ask is, what's the business model and how will you be making money? So can you tell us a little bit more about that?
So we have the world's most powerful quantum computer right now. And so there are a lot of people that want to pay us to get access to this computer. So we work with customers that just want to access our computer either through the cloud or directly from us. We also have many countries that are knocking on our door and wanting to buy a computer for their country. In addition, we also do a lot of software development. So today we published some work we've done with Fidelity. Yesterday we published some work we've done with Goldman Sachs. So a lot of what we do as a company is develop software that's optimized for our hardware to try to bring out innovation, in whatever problems we're solving. So this will add up as the computers advance.
So in some way, you are a little bit like IBM in the 70s, where you both developed the hardware and the software.
Exactly.
And how do you avoid the challenge that IBM had, that somebody called Bill Gates showed up and undermined the PC business model for?
Well, so what's very interesting is there are many different ways to develop a quantum computer. And so we don't know 5 years from now who will have the leading quantum computer, if it will still be our company or it will be something completely different. So that's part of this game, that there is a lot of competition and there is a lot of innovation. And we're just hoping that with the funding we have and our scientific strength, that we will continue to lead it.
Great. One of the, when I teach strategy, one of the takeaways that people have when they study successes and failures of kind of technology stories in the past is companies which have succeeded building ecosystems around their products. They tended to perform better than companies which were sort of single product or a single component play. And this is the quote from Nokia talking about their demise, saying that we did not lose to a product, we lost to an ecosystem. And of course, they meant to Apple. So Kevin, when you look at the European ecosystem around quantum, so clearly governments are playing the big role, but who would be the other players around which this ecosystem is developing?
Yeah. So on the one side, I would say the companies themselves, right? When I've seen in the past, as you were just saying, like the Nokia statement, companies started this journey on their own, right? And then opened up maybe later. And each and everyone wanted to protect their IP and things like that. In quantum, I see this a little bit differently. So what I was just mentioning is this, for example, Q-Tech consortium, where companies directly go together, say we have to do and want to do this jointly. So there's from my point of view, a clear openness to handle this a little bit like a community and open source consortium. That's one thing. On the other side, we also clearly see that, and it's not only Germany or Europe, right? What Denise was also mentioning, we clearly see that also the kind of hardware player in the world coming closer together. We see that research institutes are moving jointly so that this gets a really solid and powerful community, and you call it ecosystem community, who is willing to work together, help each other to make the quantum journey as fast as possible. And I think there was also a question in the chat I have already seen, right? No one in the world alone can solve these problems and challenges. For example, we have done, especially for the supply chain problem, what we call supply chain resilience 360, a joint effort with hardware player, with the MIT, with Accenture, with other partners, with the industry, to try it really out and see what is the art of the possible today and where can this bring us.
All right. Well, if we'll continue the chat, there's actually quite a few questions there already from our participants. So Denise, there is a question about cybersecurity. So what would be the impact of quantum computing on cybersecurity?
So as quantum computers grow in their capabilities, they will be able to very quickly unravel today's current cybersecurity standards. So there is a lot of work going on right now in different standards bodies in different countries where they're trying to redefine security standards to develop keys and ways to block against intrusion by quantum computers. The technology is not here today, but given the fact that it generally takes so much time to implement new security keys and new security strategies, many companies are starting to investigate their cybersecurity point of view with respect to quantum right now.
So it seems like this is a potentially extremely powerful tool. And there is work right now to lay the foundation for how this tool will be used for, I suppose, defense, and maybe some people are thinking about offense as well.
So that's true. I always say there's a good and bad side to quantum. The good side is the potential for all this application development and kind of innovation. But on the negative side, quantum computers will be very powerful, and we have to learn how to protect against them as well.
Well, speaking about the power, so Kevin, there is a question about distributed ledgers and cryptocurrency, because ever since I started to study that interesting world of blockchain and crypto, there has been this lingering worry that Bitcoin and all the other protocols will be, and Ethereum will be undermined if there is the quantum computer that comes and breaks the code and breaks the security protocol. So, from your standpoint, does quantum computing pose a threat to distributed ledgers and cryptocurrency today? And if not, maybe when do you think that could be a challenge?
Yeah, so that's a very good question. So, I mean, first of all, what we also see not only in regards to the security question, right? This is still in theory, right? It's still theory. And we also see that organizations and people already have started to build this post-quantum security idea and approach, right? Because it's the same for, let's say, autonomous driving. There is also big fear once the quantum computer is there, that this might have a big security impact for self-driving cars. And also there people already start to think about how can you protect that. So it's not a straightforward answer from my point of view, but it is what it is. So we are talking about a super young and not that mature technology, whereas a super important one.
All right, thank you. And Denise, I see a very interesting question from Julia. Will companies need to invest in parallel technology infrastructure for quantum computing in addition to their current tech infrastructure? And if so, what kind of investments are we talking about here?
So right now, quantum computers are actually very big. They're, I don't know, the size of a room or 10 by 10 room. So it's not a device that most people would put in a data center. So where people are accessing it currently is through the cloud. Now, part of what IonQ is doing is we are developing smaller and smaller computers. So with every generation of computer we develop, it's smaller in size. And our roadmap shows that we will have a box that you could put in a data center in 2023. So I think that overall the industry will move to giving people the opportunity to have the hardware themselves in their data center behind their firewall if they choose, or they can continue to access it through the cloud through the major providers. So it's still really up in the air whether people are going to want to have one in the data center or whether they're going to simply continue to access it through the cloud.
Interesting. As a follow-up question, there is a question we just got upvoted from anonymous attendee. So whoever that person is, but that person is asking an interesting question, probably back to you also, Denise. How does your company share value with cloud providers?
How do we share value with cloud providers?
So I think what maybe what this person means is, again, so what is your business model? Because if you allow company like BMW access quantum computing on Amazon Web Services, for example, or on Google Cloud, and let's say they pay some money without sort of divulging any sort of proprietary secrets or whatever. So how is the how is the value split between you, the hardware developer, and the hosting, the cloud company?
That's kind of a tough question, but let me try to answer it. So, of course, the web providers do make money off of reselling our computer time. So there is that. And also the cloud providers want very much to offer their large customer sets the ability to do quantum computing. So it's very attractive to them to offer another modality of computing to their customers. I will point out, though, that as some of the users get bigger and bigger, they don't want to go through a third party and they come directly through us, and then they buy something like a subscription. We've had cases where people don't want to queue on the cloud, or they want to run a very big job and they don't want to wait. And for that reason, they'll come to us directly, where they can reserve time and do some very big runs. So there will be a shift, and there will be some people that access on the cloud, but we also believe that the larger users will come to us directly, simply because they don't want the queuing time and they want to just be able to schedule things and get a lot of work done.
So essentially, you have those rooms where there are those quantum computers and people could come directly to you and rent their capacity.
Yeah.
All right, amazing. Just sounds a little bit like supercomputers way back in the 60s or in the 70s, right?
So your analogy, and you're perfect. We are in the 60s or 70s in quantum computing as compared to what we know with classical computers. So the technology is very much emerging, and sometimes we'll all show pictures of old computers just to try to frame people really where we are today. I think that it's very easy to get really excited and kind of oversell the technology. And so I love that you keep on saying 60s or 70s, because it still is emerging. It's not there yet.
All right. Well, Kevin, David has a question. I imagine governments are the earliest adopters of quantum computing. So from your standpoint, what are the quantum computing use cases for governments?
For governments, that's a good one. That's a good one. I think these security use cases we are seeing might be one. What we're also discussing with clients in that space is especially also fraud detection, which could be something relevant for that. Fraud detection, crime prediction is something. We have seen patrol assignments could be something. There is also something about screening, which then also goes into the area of more or less security. So these are, it's more security and fraud and crime, what we have seen in the public services. Yes, for sure, there are also things around how can you risk management, real estate stuff, and things like that. Yeah? So as Denise also said, the ideas are there, right? Ideas are there. What will be implemented first? We will see.
Mm-hmm. And a question from Felix, maybe to you, Denise. So are there currently any quantum business cases that do not depend on future technological progress? In other words, is there any money being made solely on the current state of the art?
Oh, I would probably say no. So there's no money being made right now, i.e. there are no enterprise applications that are run on a quantum computer that, I'm going to say, cost less or provide enhanced performance over classical. So that is the kind of the holy grail, that even though we have these small computers, how soon can we develop applications that are really useful? And I think you'll see, I think it's going to be in the next year or two, you will start seeing examples where people can define a problem that's small enough that the quantum computer can provide advantage. So I think we're close, but we're not yet there.
Mm-hmm. And Kevin, so from your vantage point, when you see lots of different companies trying to break into this sort of quantum space, so what are the biggest limitations of quantum computing that we should be aware of?
So I think, I mean, one thing for sure is, as we already heard, the technology is not that or too mature in the moment, right? But this will change over time. What companies, and we have interviewed also relevant C-level people worldwide as part of our research arm of Accenture. The biggest challenge these C-levels and companies see is especially in the area of talent, the missing talent. So I think also important here for the audience who is interested. So in case you want to have a great future, at least in technology, quantum is not the worst thing to bet on. So that's a big limitation these companies are in the moment facing and seeing.
Mm-hmm. And Denise, quick question back to you. So when you are working with clients through the cloud providers, are there different options that clients could subscribe to? I'm thinking the equivalent, I could rent, 15 gigabytes from Google Drive, or 30 gigabytes or 45 gigabytes, right? So in your case, can BMW rent one quantum processor, 50 qubits, 40 qubits, 60 qubits? So is there such a possibility for the clients?
So it's either they run it on our system or they run it on another system. So they can't size the system. So clients have a menu of different providers, and each computer kind of has its own capabilities or personality. And it's up to the client to decide which computer they want to use. But they either use it or they don't. They can't say, I only want 20 qubits and it has 40 or whatever. It's just, I choose brand A or I choose brand B.
All right. And I thank you for the answer. And I see that Kevin is typing an answer to a question from an anonymous attendee, which has been upvoted by 7 folks. Can you give us a specific problem that you solved with quantum computing? INSEAD audience, of course, is very patient, but they want a specific evidence of a specific problem that you folks have solved. So, Kevin, what can you tell us?
I was just typing that answer because a lot of people were liking this question, right? So what we are, right now doing since a few weeks is we are participating in a hackathon in the mobility space, right? And the industry problem is to really optimize the sensors in a car, so the positions and also the amount of sensors for autonomous driving, because this has a huge impact, cost impact, if you make it better than the rest of the world, right? And that's something where we are using quantum in the moment, trying it out, have used also different kind of hardwares and approaches. Not saying that maybe with the actual computers available, more mature, this would not have been possible, but we see already a clear advantage of using that technology. So
and what is that advantage?
So the advantage is that at the end of the day, so then we have to go deeper into this use case. So the big advantage is that first of all, you are much faster in getting to the results, which at the end of the day, if you think about autonomous driving, so to train these models, you have to move more than 600 petabytes from left to right in 4 weeks. And if you don't have to do this with this kind of big data, right, portion, this is much less in terms of what you have to spend in costs, right?
But presumably in the autonomous driving scenario, you're not going to be moving this data all the way to the cloud. Would you be doing these calculations right inside the car, or where we say moving the data? So where is the data being moved around in that specific use case?
Yeah, so there's a concept which is called hardware in the loop and software in the loop, right? So you're not completely moving that into the clouds then to calculate. So part of that you're doing directly in the kind of computer you have in the car. So, I mean, if someone is interested, we can have a special session on that. But this is definitely a use case where we already see advantages and we are trying this out. And there is a second one. So we have jointly with the life science client worked by using quantum computing on a kind of creation of and combination for new drugs, where we have also used the quantum computer. So I'm not that super expert in that space, but this is also something where we have used it already with and for the industry, and looks also quite promising, but also still at the starting point.
Denise, so to that specific question, any concrete problems that you already have solved with the quantum computing?
We have approached problems on a very small level. And so if you guys Google IonQ and fidelity, you can see a paper that we published and announced today, where we looked at the relationship between two stock prices. And this is all public stock prices. So there are some approaches to problems that we're developing that obviously need to expand, both with the computer and with kind of enterprise software. But we do have tips, or kind of, we do have, you know, we are starting to be able to approach problems, and it's very promising. I think you're on mute, Andrew.
Yeah, I know. Now I
Yeah.
see. So as we're coming to the last sort of 10 minutes of our conversation, and you already started to touch on this, Kevin and Denise, the notion of talent, right? And one of the things that Denise has mentioned is the lack of diversity in this particular space. So how do you know, Kevin, how do you see quantum attracting talents from diverse backgrounds? Is there any specific outreach programs that should be done? So, because obviously we know that diversity is valuable, diversity is the right thing. So how does the industry deal with this problem?
Yeah, also here, I think the industry has learned from other technologies and backgrounds which are now more mature. I mean, when we talk quantum is not only technology, right? So that means you also have to find people who are kind of strategists. And typically in the strategy space, the ratio of female and male are equal, right? Whereas in technology, this is not always the case. What we also see is that companies are already starting to cross-train their actual workforce, for example, their data scientists, right? So that's something what they're already doing to get people and talents who are learning on their way on the job, right? We also see that there are special programs, external programs applicable for employees from our clients. So there are different ways of tackling this and trying to solve this problem. Yeah. Also the kind of way of thinking when it comes to where you are getting the talents in terms of location, right? They think more and more global. And with all this COVID situation we are in, I mean, working virtually is most of the times not a problem at all anymore, right? So that means also sourcing options from global areas are on top of their mind.
Okay, well, Denise, so how do you see the potential solutions to diversity problem in quantum? So what can be done to attract more people with diverse background into this, what seems like an amazing high growth business space?
Good question. I started an organization called Women in Quantum just because I've seen over the years how few women there are in the ecosystem. And so part of what I'm trying to do, this is kind of my project, kind of my thing, is help other women in this industry. We've created a mentoring program. We have events where we highlight women's accomplishments. So what I'm trying to do and what our organization is trying to do is just to bring contributions by women into the forefront and encourage companies to have diversity in their offering, in their employees. And I think we have seen lately that there are more and more women and more diversity, which is, I think, really good for any business, but it takes all of us to consciously make the decision to try to make this happen. And so I work really hard just to get people to start thinking about it.
Yeah, and obviously showing the role models is one of the ways to go. And I think one of the probably hopefully useful things that will come out of this webinar is talking about, you know, role models in this industry and how you, Denise, could be in the driving seat of this new and exciting startup. All right. Well, I think our webinar is coming to the end. I think, you know, I had some questions that I wanted to ask, and I'm very happy for Denise and Kevin for answering them. And I think our alumni and MBA and executive MBA community have asked you questions, and, you know, thank you for for answering. Before we go, maybe, you know, 30 seconds words of wisdom on any topic related to quantum. Maybe start with Denise and then go to Kevin. Anything that you would want our webinar participants to remember after this session?
I would just encourage all of you to take a little bit of time and learn more about this industry. I think it's something we all need to know about for the future. And so I encourage you to watch a video or read an article and just stay on the lookout and start kind of your own self-education on this. So please look on the internet. There's a ton of material, and find something you like and just spend a little time and learn about it.
Okay, very actionable step. Kevin?
I would just say, just do it. Right? Remember, just do it. It's nothing you should have fear about, or you should think twice. Can I do this? Is it relevant? No, you can, and it's relevant. Just do it. It will be a big opportunity, no matter what your background is. And maybe also relating a little bit when we talked earlier, the question on diverse, right? It's not only on male and female, it's also about diverse education background, about diverse and different kind of things and stuff we have learned and studied, right? You can do this, and it's important, and it can be a big opportunity. So just do it.
And the INSEAD community, of course, has always prided itself on its diversity. So you're preaching to the choir here. So Denise, Kevin, thank you so much. You know, maybe in a couple of years we should meet again, and then we could reflect on the amazing progress that this technology has made and some of the problems that it has solved. Thanks again. And for the audience, please stay tuned to the other exciting webinars that are coming in the months of September and October. We are looking forward to providing you with more insights about emerging technologies, business models, and everything exciting from the business school for the world. Thank you very much. This was Andrew Shipilov, and hope you stay well and enjoy the sunshine where the sun is up right now. Thank you very much. Goodbye.